I'm the chief scientist at Lucid Imagination, also one of the co-founders of the company. I've been a long time Lucid and Solr contributor, committer, etc. Also started the Apache Mahout project along with a couple of other people. So happy to be here and excited to talk about some of the things that I've been doing and in terms of looking at how to marry Hadoop with search, how to marry Hadoop and Mahout and search and all of these things together, and to kind of this theme of what I like to call search discovery and analytics, or you often hear me refer to it as SDA. So if you hear that, that's what I'm talking about here. Before I kind of get started and into the talk, I kind of wanted to set the stage a little bit about why I think this is important and where we are in terms of the state of search and these various tools that you guys are all trying to deploy to get a better understanding of what people are doing with your content. And so I kind of like this, this old theme of the king is dead, long live king. Search is dead, long live search. I've been continuously hearing about how, if you look at the broader market, all the enterprise search companies have all been bought out, Autonomy, Vivissimo, Endeca, Fast, etc. Search is dead, right? Well, I'm here, our company's here, we've been doing this, I've been talking to a lot of you. Search is far from dead. In fact, just a poll of the room, how many people know how to do a search in a keyword box on Google or on Yahoo, right? You all know how to do search, right? Search is long from dead, right? And the thing I think that's interesting about why many people feel search is dead is in many reasons due to the fact that things like Lucid and Solr have made it so easy for you to do good keyword search right out of the box. You can go and have Solr up and running or similar tools like it up and running in almost no time. I've been on client engagements where we've been in production in less than like 3 or 4 weeks, okay? And at very large scales and with good quality results. But what typically happens is as soon as you have that, well, you guys are all engineers. What does business say next? Well, what can you do for me lately, right? And really, the state of search now is that the bar has been significantly raised. When we first started Lucid 4 years ago, the large majority of contracts, et cetera, that we did were all about how do we tune this thing, how do we stand it up, how do we make it work. Now almost all of the work that we do is all around how can I make this better? How can I make it scale out a whole lot more? How can I get, and this is really the key part, and this is why I think this SDA notion is important, how can we get better results out of that? How can we better understand what people are doing with their content? How can we as a business better monetize that, save money, all of those good things that you all want to do? And I think kind of this Venn diagram here kind of gets at where I think a lot of this is about, and the last bullet point there, basically, you need to have this holistic view of your data and your users. If you kind of look at the evolution of search and content access over the years, well, way back when in the 60s, 70s, whenever, there was a lot of really smart people that did a whole lot of work about creating things like inverted indexes, et cetera, ways of modeling documents, right? And of course, the very next thing they did, the lower one, well, how do we access those inverted documents? Okay, let's type keywords into a search box, and we can do that. And then that was good. And then we added, oh, well, I really don't even want to type keywords with Booleans and things like that. I want to ask just natural language questions. And so we spent a lot of time on access, right? And then, this little company called Google came along and other people who did a whole bunch of work around, okay, the problem isn't that we have too little data and we just need to find that one little thing. We really have way too much data. How can we better organize that so that we can move up the chain and give people really the key things that they want? And so they started to look into more of the content relationships, things like PageRank, et cetera. How can we link content together to get a better idea of what people are doing with the data? What are the important relationships in the data? And of course, you can do other things like natural language processing, et cetera, to get a better sense of some of these relationships. And I would posit that now we're in this stage, and this is in many ways what's driving a lot of the big data, is we're in this stage now of, okay, all three of those things are good. How do we bring the users back into the equation? How do we figure out what the users are doing with that content? And the beauty of this to me is the fact that all of us are people, right? So it's good to have the users and the people back into the equation here. So you're starting to look at not only just the data, but all of the users and what they're doing with that data. So take a large corporation where you have 50, 60,000, 100,000 employees, and you want to find out who is the expert within the company on Lucid. Well, how do you do that, right? You could maybe have everybody sign up and you post all their resumes, and you could do old enterprise search kind of model. And maybe if they were really good about putting keywords on things, you would probably get you'd probably get a good idea. Or you could take a big data approach and search's ubiquitous approach and this user interaction approach, and you say, okay, I'm going to take all of that corporate communication that happens, all the emails that happen, all the instant messages, all the wiki pages that get written, and I'm just going to infer by looking at those traffic and those interactions with that content who is actually really the expert on that stuff, because they're the ones who are talking about it all of the time. And so there I think you finally have this much bigger and better picture of how people are working with their content, and that of course should lead to a better experience. So with that, kind of wanted to, this talk is a bit of a mixture between theoretical and practical, so I kind of want to talk a little bit more on the SDA background, and then I want to get into a little bit of some of the architectures. The architectures of both of what I've seen out in the public, in the community, as well as I've seen with a number of customers, as well as things I've built, and hopefully we can then kind of talk about what are some of the practical aspects of this, and then we can wrap it up, okay? So in terms of why search discovery and analytics, why SDA, I mean, I think, you know, as the picture on the left really gets at here, this is all about how can we create kind of a virtuous cycle where these things feed into each other. If you think about what a user needs, well, having large-scale batch processing is really great for an engineer and all of that, but me as a user, I want real-time ad hoc access to that capability. I'm pretty smart. I know how to type in keywords, right? We all know how to type in keywords. Let's not retrain everybody on those things. I'm not going to teach you how to write pig necessarily. Well, maybe you guys, but maybe not everybody else. And so I want to give you those tools that you already know how to use. And I want you to be able to use your brain to figure out where things are. But I also want to be able to supplement that with some of these machine smarts that we've all been hearing about, things like machine learning and all this analytics, so that you can do some of these other things that you really care about. This notion of aggressive prioritization on importance, right? Just think about in your day-to-day life with email, right? I know we've all had this experience. Email is brutally time-based, right? Everything comes into the top of your inbox, and if it falls off the bottom, how many people go and look at it, right? Very few. So you have this very time-based, time-critical interaction with email, and we all have this nagging suspicion that we're missing something, right? See, what you want here is, I think, tools, this is where the machines can help out. How can you bring this notion of importance? How can you bring kind of the serendipitous discovery back into the equation so that you can bring back up this content that you're missing or this content that is related? Imagine if you're a large organization and you have some really popular content, and then you have some not so popular content, and every time you look at it as the person who's written that content, you say, well, I don't understand why nobody cares about this content. And so if you have these kinds of tools where you can start to see these relationships between this content, then you can think about ways that you could perhaps improve that such that it, you know, gets better monetization, better usage, whatever, et cetera. So all of that, of course, we need to learn from. We need to learn from this. We need to learn what's important for you. We need to learn what's important for you. It's not just about the machines just trying to make their best guesses. They need to take all of our feedback too. So that's really, in many ways, what the user needs. If we put on our business hats, we're all here to make, make a living, et cetera. The business really is after a lot deeper insight into what users are doing, right? They want to know, where they're spending their money, where we can save money, all of those things. They also are sick and tired of being told, I've got to go learn yet another system, right? Again, that poll, we all know how to do search. Let's see if we can leverage search for these kinds of things. And of course, they want these tools to all be cost effective, right? That's the beauty of open source, et cetera. So, most of you, I'm assuming, are developers. I haven't forgotten about you. What do the developers need to really build out something like this large-scale SDA engine? A number of things. As you already heard, I work on Lucid and Solr. I'm a search guy. I've been doing search for a long time. So obviously, I feel search is a very important part of this. And of course, you want that to be very fast and efficient and scalable. You want to be able to do real time with it, but you also want to be able to do large-scale bulk ingestion of all your content, get it in as fast as possible. And you really, since we're at a Hadoop concert, we're at a Hadoop concert. That's good. We'll call it that from now on. We're at a Hadoop conference. You know, in many ways, we need search to be able to keep up with Hadoop, right? This isn't just, you know, in Hadoop you can go store lots of things, but, you know, search is a really process-intensive task, right? You've got to go in and you've got to tokenize the content, you've got to parse it out, you've got to invert it into this inverted index thing. So that's a lot of work, right? So we really need to push the bounds of search to be able to do that. Well, the good news is, you can now do those things in Lucene. For instance, you know, if you take something like Twitter, they're using Lucene every day for their search at, you know, I don't know what the latest numbers are, you know, hundreds of millions of updates a day and lots of queries, right? So very large scale. And oh, by the way, they're doing it all in near real time. You can do all of those kinds of things in Lucene and Solr right now. And of course, the other part about this is you really need this large-scale, cost-effective storage and processing capabilities, right? Anybody know what that is? That's Hadoop, or Hadoop-like ecosystem things, HBase, et cetera, right? And you need to be able to, essentially, you need to be able to take all of your data and crunch through it all of the time, right? I was at this pretty large e-commerce company a few months back, and with their old system, it basically only allowed them to effectively look at and ask questions of about 3 months of data. Now, sure, they had all of their older data in archive formats, often the thing, and often some warehouse somewhere, a data center somewhere. But in order for them, all they had that described that was all the aggregates and rollups that they had already calculated. So they were building out a Hadoop cluster, like we've all heard so many times here these past 2 days, to be able to look at and ask questions of that data at any point in time based on whatever they want to do, right? So you need that large-scale consumption of all the data in order to get a better sense of what's going on. And of course, you need some other things that I'll get into a bit more here in terms of being able to sample that data, being able to work with it in a variety of different ways, being able to effectively run experiments, and I'll talk about that a bit more because I think that's one of the key things that separates from what we see in our customers from the ones who are really being effective with search and the ones who are just kind of getting by. And then last but not least, you know, this stuff is all text, a lot of it, so you need tools that can help you handle the vagaries and the ambiguities of the human language. So natural language processing and machine learning tools that can scale out are also quite useful. So kind of a high-level architecture. This is my view of the world. There's other views of the world here. I'm not putting this out as the only one. I've seen this in a number of places, not just my own. Essentially what you have, and I don't have a pointer here, but I like to think of this, you know, computation and storage layer is essentially what you're doing is combining large-scale distributed processing capabilities with search, and then you often have some type of database component in there as well. And this kind of forms the operating system layer of an SDA application. Some of the key things I think that are important here is that lower part of that, the shards, the logs, and the distributed file system. The important thing that you need in a system like this, right, is to make sure that the data is in the right place at the right time. When you want to do search and have ad hoc access, you need to have that data in the search system. And when you want to do these large-scale bulk computations, et cetera, you need to have it in the distributed file system so that you can do MapReduce on it or whatever. And oh, by the way, those logs, that's you and me, right? That's all the interactions that you're doing with all of that content. And that really helps drive, you know, having those things in the right place as well helps drive the upper layers. Now, the upper layers, this SDA layer, is all about building out and giving you the tools to figure out what's going on with that content, right? So the document access, well, that's just a, you know, glorified way of you can do search across it, you can you know, get at documents by ID, et cetera, do key value lookups. The machine learning pieces, a lot of that comes down to things like clustering and classification and organization kinds of tools that help you look at whole indexes or all of your users, et cetera, and try to develop models around what's important in there. And then it's, you know, it's really nice to have some type of stats package so that you can crunch numbers on this kind of stuff. And all of that kind of sits on top of this notion of an experiment management layer, because I think, as we'll talk a little bit more later, that is really important because, you know, as hard as search has been for a long time, all this machine learning stuff it requires a whole lot more experimentation than what you typically have even seen in the search space, which is also, of course, a subjective and fuzzy problem, okay? Tie it all together on the right with glue, throw some provisioning and monitoring and infrastructure stuff underneath, and then, of course, the big problem, the dirty little secret that we all face, right, is how do I actually get my content into this system? So, yeah, you need crawlers or processing NAT capabilities, hook it up to SharePoint databases, all of that kind of stuff, right? What does this look like for what I've been building on and what I'm kind of talking about in this talk? Hadoop, HBase, Solr. Built this out a couple of times. I've seen a number of people build this out. You can actually build it out without, you can plug in a lot of different things here, but that's essentially the idea of the operating system layer. And we'll get into some of the more of the details here. For me, up at the top layer, the SDA layer, we're talking about things like PIG, Mahout, the R statistical the open source project. Gate, if you haven't heard of it, is a natural language processing framework that does things like named entity recognition, et cetera. There's a whole bunch of open source projects here that fit into those. There's also a whole bunch of proprietary and commercial ones that fit there as well. Over on the side, the glue, well, you need something that coordinates all of these things, because if you're really going to do this at scale, you need to be able to separate out and control who's running what, when, and where, and be able to coordinate the services behind them. Everybody's got Zookeeper, it seems. Let's build on top of that and use that for things like service discovery, et cetera. And that's all well and good. At the bottom layer, we picked Chef for our provisioning. We use Zabbix for a lot of our monitoring, although most of our monitoring is actually just coming from JMX, and then you're collecting JMX. I've seen, you can throw in Ganglia or any of the other ones there. Those all work, okay? And then kind of at the top, what do we need to get at it? We kind of want a single unified API across all of this. JSON REST-based stuff seems to be the flavor of the day, so let's do that. In terms of digging in a little bit into the computation and storage layer, again, these three pillars, Solr, Hadoop, and HBase, they actually bring up some interesting questions when you build out a lot of this system. Naturally, the only thing in this picture that really has been doing search for a long time is Solr and Lucid, et cetera. You can actually, I've seen people have started to do some crude implementations of search on HBase and or things like Accumulo, et cetera. But by far and away, the tooling around Solr and Lucid are quite sophisticated when it comes to search. You get into some interesting questions of whether you should use Solr as the authoritative store. I don't totally have the answer for that. I actually had somebody ask me that question earlier today. We kind of do a mixture in our model, but it's a really interesting problem because HBase has a number of the properties that you want for that kind of thing, and I think Solr actually has, especially Solr 4, has a number of the properties that you want for that kind of thing. And so it gets to be an interesting mix, and then of course if you try to do both, then you've got synchronization problems. Of course, Solr needs to scale out and distribute easily, and so if you haven't paid attention to Solr in recent memory, this new notion of Solr Cloud makes a lot of that easy. It uses Zookeeper, et cetera. It coordinates who's up and who's down and who's available for work, et cetera. On the Hadoop side, pretty straightforward for a lot of this. We want to be able to store pretty much everything. We want to be able to drive large-scale bulk indexing through things like MapReduce. I think you all probably know the story that, of course, MapReduce, the original use case, the original place Hadoop was created was as part of Lucid to drive large-scale bulk creation of the indexes. I think many of us have forgotten that, but that's the case. The interesting thing with Hadoop is, like, when you're trying to get all your data in, if you've got a whole bunch of Office documents, et cetera, this whole notion of small files in Hadoop gets to be kind of a pain in the butt, and so you spend a lot of work, building large sequence files, et cetera, and out of these various kinds of formats, and that gets to be a little bit painful at times. For us, the HBase, we primarily are looking at using it as an analytics store. All of the analytics jobs that we run, we just throw them into HBase, put timestamps on them, and then we can start to do time series kinds of questions around them. We haven't put it in yet, but we are looking at, and I've seen this done by other people, every single query, every single interaction a user ever does with your system, just throw that into a table as well, and that's all good. Some of the interesting challenges you get here is, where should you do the work, right? So, like I said earlier, I mean, each of these systems has various properties where you can calculate things, right? So like in solar, if you're doing things like faceting or solar can do some aggregations, but it's maybe not as general purpose as what you would do in a MapReduce job or an HBase. But yet, when you have this inverted index, you can start to ask interesting questions of it that you maybe can't get out of Hadoop easily unless you're going to write a whole bunch of joins, et cetera. So it gets to be some interesting questions about, we constantly as a development team ask ourselves, well, where's the best place to do this kind of computation? And, I mean, it seems to be the mindset that, you have to kind of pick and choose and test, et cetera. And so, those are some of the challenges that we're facing on kind of the computation and storage layer. In terms of actually putting the search in practice, I've done a lot of engagements with customers, et cetera. I've done build out a lot of search systems. Primarily, you can break down search and practice into three things. People care about how fast they can make it go and how large they can make it go. What's the relevance? And then, what's the operational side of that? The business guys are always hammering me about the relevance. The techies are always hammering me about the performance, and so I always feel kind of stuck in the middle. But in terms of the performance side, so for you techies, if you've been doing solar, just a few tips around those things. Solar doing large scale and near real time is pretty simple these days if you're working off of what will be 4.0. The eternal question, when's 4.0 going to be released? It should be here in the next, as an alpha in the next few weeks. Okay, I think you can quote me on that one. But with open source, you always get a give or take of whatever the original time quoted, I think. So some of the cool things in Solar Cloud, basically, it looks a lot more like these NoSQL document databases, but oh, by the way, we build off of search right off the bat. So one of the things you often see with these NoSQL stores is what is the first thing they go do after they get all of the core capabilities in place? Anyone? They add Lucid or search into the equation because, hey, great, I got a key value store. What's the next thing? Oh, I want to search the values. Of course, that's search. I think with Solar 4, just use the search engine. It works. We've been doing it for a long time. In fact, I can't remember the last time, knock on Formica, when we had anybody lose data or any of those kinds of things. And oh, by the way, it's a pretty darn fast key value store. Is it as fast as all of the hardcore tuned key value stores? No, but you get a whole lot more with it too. And we can do near real-time updates, et cetera. A few tips on configuring that. If you're a Solar user, those things will make sense to you. If not, you can just pretty much go set those and it'll work for you. In terms of the relevance, this kind of notion, relevance testing is really hard. And if you go look at any organization that's really serious about search or who makes their living off of search, they spend a whole lot of time about relevance, right? And they've constantly got, a number of, essentially that top bullet, always be testing. They're always testing their relevance. They're always trying to experiment, et cetera. And they actually build out fairly sophisticated systems for tracking all of that stuff. And one of the key things I think we routinely see between the companies that do search well and thus make better money, save money, et cetera, is they're tracking that stuff all of the time and they're trying different experiments. So, what our typical advice to most people, if you want to just get started with relevance, is really focus in on what are your money queries. And this is usually your top X number of queries in terms of volume. What are the most people looking for? Spend your time there at first, but of course don't ignore the long tail. You do need to sample from that because what often happens in search relevance tuning is that if you tune for specific queries, you can oftentimes do damage to the other ones, okay? Your click logs, basically this notion of tracking everything. We're starting to see, and this has been an interesting trend for me, you're starting to see companies who are actually tracking where you are on the screen at all times and sending that, right? Whereas most people for a long time in search have just been looking at, what are people actually clicking through, but I am starting to see people who are doing this whole actual mouse tracking. You talk about a big data problem, right? But it's pretty interesting nonetheless, and I think it really helps you get at, because oftentimes in search, especially the way search interfaces are built, you often can get the answer. The user may not even ever click on something, but you can get that. They're finding the answer just in the snippets that you've generated, and that may be a successful query or not. There's really still no way of knowing that, but you can maybe infer some of that based on where they spend their time. Are they scrolling up and down, et cetera. The other last kind of bit that is the little secret, I think, in many ways for search is anytime a user puts in multiple keywords, even if they don't put quotes around them, treat that thing as a phrase and look for those words together very close, and you'll often get better search. Does it work every time? Of course not. Nothing works every time in search. It's a subjective experience, but that usually works pretty well. In terms of the discovery components, what kinds of things, essentially the problem here is what kind of things can we do to help users deal with the deluge of data that they have, right? How can we help them find things that they wouldn't otherwise find? How can we encourage this serendipity? How can we better organize that content? How can we help them find out where the crap is so that they can fix it, right? On the serendipity side, all the rage on a lot of the social network stuff here is you got things like what's trending, what are the topics, what can I recommend, what items are related, all of those kinds of things. Some of the simpler things that you've had in search for a long time, like more like this, did you mean, good spell checking, all of that thing. Statistically interesting phrases. I just told you phrases that are your friend. What if you go through all of your content and look for words that co-occur together more often than what you would expect? Those are statistically interesting phrases. How can we leverage those? On the organization side, this notion of importance, I think, is gaining ground and interest. Google Priority Inbox, I think, helped bring this to the light. But this notion of, what's really important? How can we build up a model of what's important for you? This notion of clustering, essentially you're bringing together content that's similar so that you can help users discover things that they won't otherwise discover, or make decisions to ignore content that is too similar. Named entity, extraction, classification, all of those, again, are putting labels on things so that you have a better understanding of what's important. And then last but not least, believe it or not, this data quality problem, people don't put in data right. It's really weird. I always tell the story of the really large e-commerce, actually brick and mortar and e-commerce company that we did it was actually one of our first clients as a company back in 2007, and they came in and search was broken. One of their top products, this is the thing I think you all own, was broken, and it was on page 10. The actual, when you search for that thing, that result was on page 10. Now imagine, this is a large company, $1 billion of revenue, right? Think about what that means for that thing to be on page 10. So as it turns out, they actually had a data quality problem. One of the key fields that they were searching against didn't have any data in it. Nobody, whoever typed in the product description didn't do it, or they missed it, or whatever. They fixed that overnight, and voila, it was on page 1, and we've all gone on to find it much easier, right? And they've made a lot more money. The problem with a lot of this discovery stuff, and this is really where a lot of this large-scale batch computation comes in, is these are really intensive calculations in many cases. Not all of them are, but many of them are. If you're going off and doing clustering of your whole content, that often requires something like MapReduce or one of these newer frameworks that is much better at doing iterations. And the other problem here is, you tell me, what's the popular trend? Well, if you're here, Hadoop is the popular trend, but if you're, a teenager, then it's, whoever the latest pop star is, right? So figuring out those kinds of things require a lot of experimentation, and so you should plan on that right from the get-go. I guess I better hurry along. So, oh, by the way, there's this project called Mahout or Mahout. I've heard it, I think, 4 different ways now. I usually slip into my ways and call it Mahout, but I think I'm constantly told it's Mahout. Mahout does a lot of those discovery things. You heard Jeffrey Moore talk about the collaborative filtering as one of those things. Mahout actually does a lot of collaborative filtering, has a lot of collaborative filtering capabilities. I think we have most of the algorithms implemented that helped win the Netflix prize, for instance, based on our reading of the paper. It's probably the most used part of Mahout. We've also got some interesting classification capabilities. Now, warning here, right? So Mahout is about to be 0.7. There's some sharp edges in Mahout, and so you should be careful. You should go ask on the user mailing list where you're going to use things. But if I had to put them in order, I would say start, collaborative filtering. That stuff's pretty rock solid and in production at large scale places that we all use on a regular basis. Some of the classification stuff is much better than others. We have things like logistic regression. That's pretty solid. Actually doesn't use Hadoop because we don't need to. But it's very fast, and I've seen it deployed in a number of places at really large scale. The clustering stuff, we've got all the kind of the standards, k-means, et cetera. Those work pretty well, but they often suffer from this iterative problem that I was talking about earlier. And oh, by the way, we've got a bunch of other things. We've got a pretty good math library. We've got a pretty good primitive collections library, which is what you need when you're building out many of these kinds of applications. We do things like singular value decomposition, which can help you get at more of the concepts in your content. But a variety of challenges when you're actually doing Mahout. It's very command line oriented, and it's very, a lot of them are high cost for Hadoop, et cetera, because they're iterative. And as I said, some areas are less mature. So just as a little bit of aside, you've heard me talk about this experiment management before. I think this is a really important thing that, if you're going to be building a system like this, you need to bake this right in from day one, right? Or at least be thinking about how you're going to bake this in, right? Because, again, when it comes to building out classification models, clustering, all of that, there's just a whole lot of experimentation going on. And the only real way to figure out what's working is by going in and asking your users, is this effective? Well, you're not literally asking them, but you're clicking, what is their response rates constantly? And so just plan for dealing with all that data right from the get-go, right? And oh, by the way, you can actually do this right in your system as well, because you're probably using something like Pig, et cetera, that'll allow you to do that. But kinds of experimentation that you can consider there. What's your indexing scoring formulas? How are you tokenizing the content? What's your classification models? All of those kinds of things are all ripe for experimentation. The other nice thing actually about when you build this in is you can actually use this to deploy out your QA to staging to production development. You can kind of use it to track how things move through your system as well if you do it right. And the goal here really, again, is to make it easy to do these A/B tests or A through Z kind of tests, which I think is becoming more prevalent. Switching back then to the SDA, the last piece, the analytics component, what are people actually doing in real practice here? Solr actually has a number of analytics things. You guys have heard of facets or navigators before. Well, that's just a really simple way of counting things. And let's face it, a lot of the things we're doing here when it comes to analytics is counting things. So let's use Solr for some of those things. Everybody seems to be in love with R. It's a great tool. Why not use it? It gives you a lot of the stats packages that you need. And then Hive and Pig and commercial, I don't need to go into a lot of the details on there, but those are all pretty useful for crunching the numbers, as it were, when it comes to looking at your logs, et cetera. For me personally, and this may not fit with you, but in many of the engagements and customers and things that we're seeing and looking at, we're usually coming at the analytics side from a search and discovery point outwards. I'm not trying to be a general purpose analytics engine. I'm trying to get at the analytics that help me better understand what people are doing with the search and discovery system. And then you can use that as context to look at the broader capabilities that one might want. I've touched on a number of these already, but again, just kind of simple things that people often are wondering, how do I actually calculate things that are useful for relevance, et cetera? Things like mean reciprocal rank, that's just looking at what are people clicking on and figuring out that's a nice little simple number that you can use. There's other metrics like that. If you get into the information retrieval community, you can go spend all day looking at math formulas for those kinds of things. I often find also if you're looking at histograms or drill downs into the number of results that you're returning, that's often a really good indicator as well. If users are routinely getting 0 results, that's probably a bad thing. If they're routinely getting a whole lot of results, maybe you want to think about, are there ways for those kinds of queries that we can suggest to them other queries that are similar that would refine their results a lot down and further down and get better capabilities, right? And then last but not least, this whole notion of data cleanliness, right? I mean, I think there's a lot of capabilities you can do here in terms of, just like in Lucid, what if you had a tool that simply, for this customer, if they had a tool that simply said, oh, here's how many documents don't have any entries in that content field, right? And oh, by the way, that's if you already know that that's your bread and butter field that you're searching against, then wouldn't it be nice to know that 50% of your content doesn't have that field filled in? Or the other kind of thing that often happens in search systems is you spend a lot of time figuring out how to apply boosts to those documents to give some extra importance to them. That's a bit of a black art. What if you had tools that could show you the distributions of your boosts across your documents so you could start to see whether there's areas that are out of sync with what you would expect in terms of your knowledge about the data? And all of that, I think, kind of starts at what you want to get at in terms of the analytics. Again, looking at it from search and discovery outwards, there's obviously a lot more you can do here. I won't pretend to be exhaustive on this. Wrapping it up, and happy to take a few minutes of questions here. Basically what I think you're starting to see evolve is this, is actually we're moving up the stack here in terms of, we've got this distribution of Hadoop and HBase and Hive and all of these things, and those are all, a nice set of parts. How can we move up, put those together into something that is effective for actually better understanding our content? I would posit that this notion of SDA is what that is. I'd be remiss, we've got a product out that we've built on this. And last but not least, I would say design for the big picture when you're building out these search-based applications. You really want to think about how you're going to capture what your users are actually doing with that content. So build those things in right from day one. And I think that's about it. Happy to take some questions. That's where you can find me. Thank you. So I think we've got a couple minutes. If you've got questions, come up to the microphone and ask. Otherwise, anyone? All right, Amit. Oh, he's going to give me a hard one. I don't think the mic's on, the back mic is on.
Perfect. For the experiment management tool that you've got, is that meant to integrate with your front-end UI?
Is it what?
Is it meant to integrate with your front-end UI as opposed to just the back-end search engine?
I mean, I think what you end up doing in these situations is, all of your, all of the parameters that you send in about user profile, et cetera, that's all on your logs, and then this tool will help you, crank through that kind of and separate out all of those things, right? And then you want to feed that into your admin UI, but it doesn't necessarily go into the main UI. But typically on the front end, what you're doing is you're sending tracking information through that identifies what experiment you're running, so that you know, right? Yep.
You mentioned to integrate Solr with Mahout, right? So my documents are already stored, in my NoSQL database. Could you explain how I can use Solr to run my machine learning?
So, like the Mahout Solr stuff, what we're typically doing there is that's like if you're doing something like clustering, that's done up front, and then you can index the cluster IDs into the index, or you can dump out like Mahout has capabilities of reading in a Lucid index and then dumping out and then doing the clustering that way. So it's not a super tight integration, but it's typically not something you need to do right there. If you're doing classification, then that's much easier to hook in at like the analysis process to figure out what the labels are.
So is it taking a shortcut then? Like, if you're trying...
I think we're out of time, so why don't we come take this offline?
Okay.
Sorry.
Okay.
Thanks again, everyone.